What's up, guys? We're doing practice problems. We've hit into 1.9 now. We're looking at number 1, and we've got this image of a book that's shown on a website. So you're looking at a website, and you notice that there is an image on the website, and its measurements are as follows. We've got 1.5 by 3 inches tall, so it's twice as tall as it is wide. So we've got 1.5 inches tall and 3 inches tall on the computer screen, and it's an image of a book. Okay, so maybe somebody's on Amazon checking it out. The actual book is 9 inches wide. So the image is what we would consider to be a drawing, and the actual book, whenever you look at this picture in your hands, it's 9 inches wide. So what's happened here is we've got a scale drawing. So what we want to do when we have a scale drawing is we want to take we want to look at the corresponding parts. So imagine this is the image, right? But the actual book is much wider. And you've got to look for these key terms for correspondence. 1.5 inches wide, 9 inches wide. So if you were going to draw like a version of this, and this is not to scale, so it's not going to match, but it's going to be another rectangle, but the actual book is going to measure 9 inches wide, like so. Alright, so there was a change. You know, the real book is bigger than what they see on the website, and there was a change from these two right here, and that's the scale that they're asking about. What scale is being used for the image? And really they want to know the backward scaling, because it started bigger and it got smaller. So our answer is going to be a fraction. And that fraction is actually pretty easy to set up. It's just the corresponding part set into a ratio. So for this one, we're going to take 1.5 and 9, and we're going to set up with the 1.5 on top, because we know that it's going to be proper and be a smaller numerator. And I like to think of this as 15 and 90. So if I'm dealing with 15 and 90, I can count by 15s. That's a pretty easy number to skip count by. 15, 30, 45, 60, 75, 90. So that tells me that I've got a common factor here of essentially 15. So 15 will go into itself once, and how many times will 15 go into 90? And that would be 1, 2, 3, 4, 5, 6. So this is like a 1 to 6 ratio. Alright, so the common factor there, I mean, well, I said 15, but technically I guess it's 1500ths. So it's like dividing by, 1500ths to get that, and dividing by 1500ths to get this, which shrinks our fraction down to a sixth. And that tells me that my scale factor is a 1 to 6 ratio of multiplying from the original down to the scaled version. Now, if I wanted to come back and go the other direction, that would be times 6. So 1.5 times 6 equals 9. So those reciprocals are interchangeable. But the scale that's being used for the image, going from the original to the image, because this was our original, is a 1 to 6 ratio. It's a sixth of its size. And then how tall is the actual book? So they go on and ask another question. Well, now that you know what's happening to get these things, and we know the reciprocals, we should be able to find out how tall these corresponding parts are. The 3 corresponds over here with the height of the picture, right? And going from image to original, we multiply by 6, and 3 times 6 is 18 inches. And that's how tall the real book actually is. That's a tall book. 1.5 feet tall. It's like maybe a picture book or something. I don't know. Either way, it's 18 inches. And there's our answer for number 1.